Greeting everyone. Today, our group will like to present the microbial fuel cell as green approaches for removal of electronic waste from wastewater. Today, almost all developed countries are faced with environmental issues, primarily industrial pollution as a result of population growth and economic development. Therefore, fuel cell technologies are introduced to the world as an efficient technique to cope with environmental pollution. It uses an electrochemical process involving hydrogen and oxygen to produce power and water. Fuel cell technology are also regarded as future energy conversion devices as it provides a lot of benefits such as reduced oil consumption and pollutant emission, compatible with renewable energy and high efficiency. In this study, microbial fuel cell will be chosen as fuel cell technology that using bioelectrochemical method to degrade electronic industry wastewater. Microorganisms will be used to convert chemical energy to electrical energy by transferring electron to an electron terminal acceptor for generation of electric current. The advantages of MFC are can operate in a wide range of temperature and generate clean power without requiring separation or purification. As we know, MFC uses of renewable energy and biological processes that produce no harmful byproducts. It is environmentally friendly method and viewed as sustainable way of power production in the treatment electronic industry wastewater. The objective of this study are to utilize fuel cell technology in wastewater treatment. Second is to practice microbial fuel cell for electronic industry wastewater and produce electrical energy. And third, to fulfill the principle of green chemistry through bioelectrochemical method of MFC.
Next, the project description of the proposed method. A microbial fuel cell, MFC, is a bioelectrochemical system that utilizes energy by respiring bacteria and directly convert organic substrate to electrical energy. This type of fuel cell relies on living biocatalysts to promote electron flow throughout their systems. In this project, microbial fuel cell MFC technology will be utilized to treat electronic waste, e-waste, wastewater generated by electronic industries that cause environmental pollution in water. The application of MFC will be adapted in treatment plant construction as the input of e-waste, wastewater, and sustained for the processes of waste removal that requires 3,500 m² land of area. How does this fuel cell treat wastewater and produce electricity? First, the MFC technology utilized will be mediatorless and double chamber, whereby the respiration of bacterial cells directly into the anode electrode as an electron acceptor and part of normal metabolic activities at specific conditions. Salmonella acidosis MR1 bacteria will be used as the microorganism to degrade and metabolize the contaminant in wastewater that can be released into the graphite anode electrode. The mechanism of MFC will begin at the anode chamber. The anode and cathode chamber will be separated by proton exchange membrane PEM that allows the electrons generated by the bacteria to produce current. At the anode chamber, the bacteria will attach to the electrode surface and oxidize wastewater to generate protons. Next, the protons will pass through PEM to the cathode, and electrons that pass through from the anode to the external circuit will generate electricity. On the other hand, half of the cathode chamber is positively charged. and the electrode exposed to electron flow consists of the oxidizing agent and reduced as it accepts electron transfer from the PEM bridge. Thus, the oxygen present reacts with hydrogen to produce clean water and electricity. The major processes of wastewater treatment involve the collection of e-waste wastewater from industrial and will be pumped into an inlet pumping station to treat debris and filter the wastewater from solid, sand, and grit residues. The filtered wastewater will be transferred into wastewater vessels and further treatment with MFC technology as the primary treatment of the e-waste wastewater. The treated wastewater will be measured and analyzed with instruments such as multimeter, pH meter, methane gas analyzer, and dissolved oxygen DO meter. Subsequently, the clean water will be discharged into the environment and water quality assessment will be conducted to ensure the discharge of the clean wastewater is safe and monitor the performance of MFC technology. The application of MFC technology in wastewater treatment from the electronic industry is significant, as electronic waste has become a major problem in our modern global society. The discharge of electronic waste in wastewater may cause health risk assessment and toxicity to the environment. Hence, this project will benefit both the industrial and community as the strategy to reduce waste and supply renewable energy sources.
At the end of this project, it is expected that the fuel cell technology will be applied in the treatment of electronic industry wastewater using a microbial fuel cell device. The application of the MFC using a bioelectrochemical as a green approach in treating wastewater pollution can be achieved according to the principles of clean chemistry. Up next is the project budget. This total cost includes land requirement, materials, installation, and lastly, operation and maintenance. Firstly, the land requirement for the treatment plant requires cost around 100,000 ringgit. Next, the materials for the operation, which include chambers, electrical measurement, water pumps, and other materials required. Furthermore, the installation cost is 50,000 ringgit, which includes the cost for excavation, plumbing, plastering, flooring, and other construction operation are included as well as the cost of construction materials. Lastly, operation and maintenance is 15,000 ringgit. Moving on to the timeline of this project, this table shows the timeline for the project, which the duration is in 3 years starting from 2022 until 2024. The scope of this project are divided into 3 parts, which are the project proposal, project implementation, and lastly project evaluation. Firstly, the project implementation, where the project will be proposed to be approved by the Ministry of Environment and Water for the reduction of environmental pollution with green approaches, which is fuel cell technology. As the proposal will be approved, the project implementation will be conducted in 3 phases. In phase 1, the target group of this project and community will be informed regarding this project for 3 months starting from September to November. The construction of the treatment plant will be held from December 2022 until March 2024. In the second phase, the microbial fuel cell will be applied on the treatment plant and series of assessment will be done to monitor the performance of the fuel technology to remove the waste while generating electricity from April 2023 until March 2024. Next, in the third phase, the construction of the treatment plant and the performance of microbial fuel cell will be monitored from December 2023 until March 2024 to ensure the optimal condition of the building preparatory to the operation of MFC for the waste removal. And lastly is the project evaluation, where the progress report of the microbial fuel cell will be evaluated based on the performance and updated every month beginning from April 2022. The evaluation process is highly important to monitor the impact of this project in the environment, community, and operational of the technology. In conclusion, the application of the microbial fuel cell by using bioelectrochemical method for electronic wastewater treatment has demonstrated another potential use in waste management and pollution control. Thus, there is a definite need to treat the electronic wastewater to ensure better human health and to sustain the environment for future generations. That is all from our group. Thank you.